Please welcome our next speaker, Nikola Krgović.
Well, hello there. So if anybody wants to download the slides, they were available online. We are going to talk about running applications in a production environment. And by production environment, I mean actually having, some traffic on your website, having actual users. Most applications start by something that doesn't have any users. You build a proof of concept, you build something that works, you remind everybody that you need a minimum viable product, you probably make something that's extremely small, extremely unflexible, and let's be honest, you probably just pull up a ready-made CMS and hack some data on it until you get traffic. That's perfectly fine. You're running that on a shared hosting or on a single server. The whole point is a lot of products fail in the first couple of months, they fail in the first year, and nobody bothers to set up a system which would be sustainable for anything major because you're trying to test the market. What happens when a lot of things change? What happens when you actually have traffic? You suddenly need to have performance, you suddenly need to have users who can actually use your website. You can scale vertically, but basically scaling vertically is something that's going to cost you tremendous amounts of money once you skip from 50 users to 50,000 users on your website. And also when your web project stops being your test project and starts generating actual users, well then you kind of need it to be always available, because if it's generating your revenue and that's become your primary source of income, you're suddenly no longer comfortable with having downtimes, at least not when it's generating money. So what's going to change? You're going to change the way that you work. That's the whole point. You're going to change the application environment. You're going to change the way you develop the application, because basically most projects start with you hiring a couple of decent developers who know what they're doing, or you hope they know what you're doing, but you're not hiring the very best you can because they're expensive and you're still testing. You will have a product which could be updated whenever you want because nobody was on the website. Now you need to have a proper development methodology. You're starting to pick up on your books. You're starting to pick up on what's going on. Suddenly everybody remembers who's Uncle Bob. Suddenly everybody wants to do hexagon patterns. You have kind of figured out that WordPress can be divided into some services. You're seeing something like service-oriented architecture to a scale. Basically, you're running your database servers separately from your application servers. You are moving the admin panel to a different machine, but those are hacks. Basically, you have started calling out to senior people. You have started calling your people you didn't work before with help me Obi-Wan Kenobi kind of approach. Everybody needs help. You don't know what's going on. And you are in a big need to change because there are two things that are going to change. First of all, you need to continue the development process. And continuing the development process is going to be extremely complicated because you have a product which is no longer working as well as you would like it to work because it's gone slower, it's gone less useful. And on the other hand, you have a product which needs to keep adding new features. Which is the need of the market, because you have started to accumulate growth, you have started to accumulate customers, but you need to continue, you need to stay on the competition, you need to do whatever you want. Whatever happens, the business is requiring new features, and you need to change the internal architecture of the application so that it supports a better scalability model. That's the whole horizontal scalability thing, because basically to scale vertically is going to cost you a lot more money, and basically you still don't have infinite funds. So what's going on? You're changing your development methodology, you're suddenly remembering solid, you're suddenly remembering all those things, and you need to implement them one by one. What's going to change in the company, and what's going to change in the infrastructure, and what are the things that are going to hurt if you haven't thought of them in the beginning? Well, this is supposed to be an overview of all those things. First thing you're going to have is something they call the continuous deployment. The continuous deployment is basically an approach which is going to start with continuous delivery. That's the easy part, because continuous delivery says we're going to keep building it, and every time we build it, we are going to be able to push it to production. And then it's going to get even worse, because at one point, you will no longer have continuous delivery. Works when you have release cycles. It works when you have a single team which is delivering a product, which can have like a sprint or whatever, when you have a method for defining when changes are going to happen. And then when changes need to happen, you're going to push a button. But then, at one point, you will have a very large team. A very large team is basically anything above 25, 30 developers. And they're all going to work on their own separate parts of the project. And once that starts to happen, you can't have everybody waiting for somebody else, because there will be a lot of time lost, because one team will deliver something in 2 weeks, the other one will need 4 weeks. You need them to keep working with each other. You don't want one team to hold everybody else. And then you're moving to continuous deployment. And continuous deployment means that things will be deployed automatically. And this is becoming a major problem. Why? Because, well, if you can deliver your software to production as soon as it's ready, that relieves your software development teams of the pain of waiting for somebody else to finish. But on the other hand, it means that everything has to work. And this is one of the biggest changes you will see as a software development company, because it will change your flow and it will require a lot more testing. Why? Well, has everybody seen this slide? Yeah. So if you start pushing things in production and making sure that they work on their own, and somebody else has changed something else, then you're suddenly having big problems. The second thing you're going to do is you're going to have like somebody doing system operations properly, and that's usually what I do. And usually you want to, and these days the millennials are using the phrase DevOps, which they say which is a methodology which has come out of this very same need, which basically means that you, let's say if you worked in a bank 10 or 20 years ago, you would have had a dev team which would want to push changes as soon as it can and be done with it. And you would have had an ops team which would most likely like to have changes never, because they want the stability. The whole point is to fuse those two teams together and have them working together so that they do it in a continuous fashion. One more thing, most important thing to understand about this process is that it's a continuous process. It goes hand in hand with continuous development, and that it's not a job title. The common anti-pattern I see these days is people saying we're going to have a DevOps team. No, you're not. If you have a guy who says, I'm a DevOps engineer, honestly, he's trying to milk you for more money, or he doesn't know what he's doing. There is no DevOps engineering. There is a methodology. That's like saying I'm an agile engineer. That's the same thing. This is a developers conference. How are those things going to affect you as developers? So just a few basic changes are going to happen. One, you're going to see that the environment is now being generated using configuration management tools. This is a big deal. The second, even bigger deal, is that deployments are going to become automated. If you want continuous delivery, you're going to have deployments which are going automatically to all the machines. You're going to have auto scaling. You're going to have containers which are built. Whatever you do, you will no longer be able to do things manually. And more importantly, you will not have direct access to the production servers. The biggest problem with this is that in most cases, even your ops team is not going to have direct access to every single server which is in production. If you go with a container-based approach, which is auto-scaling, and it starts scaling up and down, there will be short-living instances which will die before somebody takes a look at what happened to them. And that's the reality, you know. The reality is also that you will no longer have the ability to ask as a developer, hey, can I log to every machine and run an artisan command? No, you can't, because we don't have access to every single machine and it takes forever. We have to automate this part, and also we have to assume that those machines will be short-lived. Also, since machines will start going up and down, this will change the life of a developer who wants to see the logs. The logs are going to become centralized. Why is this important for you? Because you're going to have to use tools which require some other knowledge. How do I access my application logs? That's a big question for a developer. How do I find out when I have a bug, what happened? Well, you're going to have to look at the logs, but you no longer have the logs in the server. You have to go to a centralized place, and that centralized place is going to have a whole database of logs, which you're going to search using some regular expressions. I'm sorry if you don't like them, but you're going to have to learn to relearn to use them. You know, it's a big problem. And also, you are going to start being forced to use application performance monitoring tools as a developer. 10 years ago, this was something that was done by the ops team, and basically we would tweak what we could out of the application and just scale it. Nowadays, the whole point of this breaking the silos thing, this whole new methodology of development, is that you as developers need to get into this. We need to show you, look guys, these database queries are slow, or look guys, these PHP processes, these Java processes are running for an extremely long amount of time, or what a colleague mentioned, this one is taking like 0.4 seconds, but it's being triggered 100,000 times a day. So yeah, we need to fix this one, and we need to shorten it out if we can. And that's going to change. When it comes to the rest, the only thing you're going to have to remember, and the only thing you're going to have to know about it, is that your infrastructure developed is going to be deployed in an automated fashion, and the only reason why a developer should care is that it guarantees to him that they will all look the same. So the whole point of this whole story is that we have moved past the point where we run our applications on the fixed amount of hardware because the traffic is going around, because we have applications which have started to breed and get bigger and smaller. We're going to have to reprovision them all the time. And when your colleagues tell you we're using some tools to provision them, that means that one, they have almost certainly been provisioned using a configuration tool which guarantees that they have been provisioned always in the same time. And what we're trying to do in the last couple of years is that we are moving to tools that actually do configuration management and not just configuration provisioning, which is a guarantee that there will be an agent, a piece of software which sits on every single server, telling us that it's going to continue to be in the same system. How does this look in practice? Well, this is a screenshot of what your monitoring system will look like, and this is the stuff we're going to have to be looking at together. So how does this look like? What's the temperature? What's the CPU status? How many queries per second do we get? These are the stuff that will be presented not just anymore to the ops team, but which we will ask the developers to take a look at. Also, we will ask you to have a look at your application performance monitoring tools, because these days, application performance monitoring tools will give you a very clear view of which part of the application is actually giving you which performance penalties. So how long is the code taking to execute? How much is the database taking? What's the total response time? What's the browser doing in this? And this is something which we are going to use so that we can get information. The screenshots are from New Relic, if you don't know what it is. Which will tell you how exactly it should look. When it comes to logs, you are also going to have a tool which has a whole set of tools, and then when you go into logging, your logs will be aggregated, and then you will have like something here which will give you refine your query, so you can search every status, let's say 400 to 499, and extension PHP or extension HTML. So you will be having a very complex query in order to filter your log results and in order to find out what went wrong. The second thing that's going to change after you switch to a production environment, and it's going to change when you start scaling both horizontally and in depth with different forms of software on the back end is going to be your development environment. Now, your development, staging, and production environments are going to try and be as similar as possible to the production. Mind you, this doesn't mean they have to be identical. We're going to set up your developer's machine, we're going to set up some code pipelines, we're going to set up your tests, then you're going to have a test system, a staging system, and a production system. The difference between a staging system and the production system is because basically they're supposed to be, what's the whole point of this? The test, staging, and production are supposed to be identical in the sense that the test should be the one you can crash, and it should have exactly the same data as the production and the staging, but indemnified. So everybody here indemnifies their product test data, right? You remove all the actual user's data, right? Oh no, okay. Okay, so the whole point, you are going to have performance on those, and on your local development, you will either have a single virtual machine trying to emulate everything, or lately, we have been trying to push a change to set up a very large amount of containers on every single developer's machine so that we can give you a system that actually mimics a horizontally scalable system. If you have the resources, which mostly means the time and the manpower, you can actually have every single developer having on his own system a very small system which completely mimics everything, which means that you will have a couple of database instances on every single machine doing master-slave replication or whatever it should be. There should be a small cluster of MongoDBs, or you should have a single load balancer, and everything should be mimicked. This is actually a very complex task, and usually means that you have a very large team, but you could be going in that direction, and you would end up running something like this. This is what a live testing OpenShift system would look like. So you would have your application deployed, and then you would have a lot of details on that application. This is about as much as in-depth you can go on a production container-based system. That's the stuff I was talking about earlier. What your application system will give you is that you will see how many pods are running. You can see the configuration, which is stored in some YAML, unfortunately, or whatever. You can see the variables, but you will also see that your system is running on many pods, and that you will be able to log into one of those if it's still running, but that's about it. Next thing you will need to change in your application, and next thing that your application will actually need to adapt to, is running in a highly available infrastructure. Highly available systems are, by definition, systems that cannot fail due to a single failure. That means they don't have a single point of failure. That's it. It doesn't mean anything else. They can be terribly inefficient systems that can be designed in an awful manner. In my experience, well-designed, highly available systems don't have redundant components. They don't have cold standbys, or don't even have warm standbys. They run in an active fashion, which would allow you to use the entire system and then just have the capacity diminished in case of failure. And in a perfect scenario, it would even allow you to automatically grow back into full capacity using scale on demand into some kind of a cloud. But even if you're running on-prem, you should be allowed to run it at full capacity using your existing system, and in the event of failure, you should have a system which will not fail if any single component fails. This doesn't mean a single instance. So this just doesn't mean my database has failed. My entire server has failed. My network switch has failed. A cable has been cut. All of those things are necessary to be checked, and I mean checked, to guarantee that your system is highly available. A true story, when we set up a highly available system, a couple of years ago, we were moving a website from Germany back to Serbia. We set up everything in Belgrade. in a data center. We took our CEO to the data center to show him everything and told him, look, you can pick a cable or you can pick a button and just push it. That's how a highly available system should look. You know, you should be able to do it. I'm going to try and give you a short overview of all the parts of this common landscape for a web application. How does it look like, what it consists of, and what you should be thinking about every single component of your web-based system while you are building it. You're not going to start thinking about it while you're building a WordPress website, obviously, but the moment you start customizing, the moment you start thinking about that solid thing, you are going to want to be aware of what it exists. So your typical components will include a load balancer, content delivery network, some application servers that obviously run your application. Commonly will include a relational database, a key value storage, a queue, some kind of document storage, and or NoSQL, or whatever you want to call it. They're going to use some shared storage, and they're going to use a full-text search. All those things usually interconnect into something like this. And the only thing a developer needs to think about is, and needs to be aware, and the management especially needs to be aware, the same solid principle that is applicable to good design of classes in a programming language, well, you should also apply single responsibility to this system. Every single system should be designed using single responsibility components. So the principles remain the same. How does this change from your system? How does moving to something like this, a big pool of things, all being single responsibility, what happens when you move an application that was so far happy running on one single machine, which cost you 50 euros a month and was running your WordPress? Let's go component by component. It starts with your load balancers. Your load balancers are going to do a couple of things for you. They are going to distribute connections, hopefully, to every single application server based on some criteria, either equally or unequally depending on them. They're going to make sure that your application servers are alive, and they're going to automatically remove the ones that are not. That's guaranteeing that your application will work. They can do some cookie stuff if you want. They'll handle all your redirection. They will handle all those things that you so far could have been handling directly on the same machine. And this is the part where we begin to really communicate. So no longer you can go and just add an htaccess file saying, yeah, I need 3 redirects. Well, we don't want to do the redirects on the application server because the application server has better things to do. It can run your applications. We want to do that stuff on the load balancer. Also, we're going to terminate all your TLS connections on the load balancer. Your internal network will probably be unencrypted. This is important because you can no longer check simply, am I receiving an HTTPS connection? In most cases, you are not. And finally, if you run in any kind of environment that values security, you will have a web application firewall running here. Web application firewalls are basically a set of rules, again, regular expressions, which will pass your content and remove critical pieces of HTTP requests. For example, a well-written web application firewall will never allow an HTTP request which contains the phrase drop table in it, because that usually doesn't go to an HTTP request, and I want to cut that out before I even reach the application server. If you have something that's not a very standard application request, you will have to test and you will have to talk to your people. How will it look from your application standpoint is that some information will be moved from standard headers to additional headers. You know, you will have an X-Rail IP header, you will have a forwarded for header, and you will have a schema to which the connection has been made if you want to think about it. The reason why you have to know this is because if so far you have been testing your remote IP as a direct connection, you will never see a remote IP in an application. Remote IP will always be the load balancer. You will have an X-Rail IP header in it. Yeah, by the way, there is a way to properly make this. I have had people who make unstandard HTTP headers. People, please don't, okay? So next thing is that you are probably going to have a content delivery network. Why is this important for an application developer building a web application? It usually consists of two things. You will have an object storage. This is the dumbest thing in the world. You upload files, you get your own files, that's it. The only thing you need to know, because I have been asked this at least 100 times in the last year, is yes, you can have it on-prem. So if you want an on-prem S3, yes, it can be done. Why are CDNs important? CDNs are important because they relieve the application infrastructure from serving static assets. I've had a system that I started maintaining a couple of years ago, where somebody who was developing it has built a new set of containers, Kubernetes containers, which only print out static assets. So basically, when you want to push a new version of CSS, you have to rebuild the entire container and do a gradual failover of the entire container network, and to gradually roll over from one container to another, you have to go to shutting them down, and each one of them has to have a new request before it shuts down. So it has one request, then it gradually shuts down, then moves to another, and if it's on a test system, you can literally have a 30-minute rollout of the new version of static assets. So people do think about content delivery networks. The second thing is, of course, content delivery networks are generally faster. I've built a couple of them on my own. Even when they are not faster, they will have extreme caching time sets. So basically, your content delivery network will send the browser a caching header which says this doesn't expire for 30 days, which means two things. One, the server will have a lot less requests, and two, you will have to version everything. This is a big deal. I know a lot of developers who start their front end without versioning. You need to think about this from day one. You need to version your assets. They even help, as I said, we built one without any external endpoints. It helps because you serve them off a cookieless domain, the headers get out, it brings actual speed to your system. How will your application servers change? Application servers need to be stateless. You can no longer have a state on an application server, because once you have load balancers, once you have hundreds of thousands of requests, not every single request is going to end up on the same server. You can no longer have a desire which says, hey, I need to have every single request on this server. That doesn't work. Your applications can be stateful, but you will have to use some kind of shared storage to store the session data. It's preferable that you don't. And also, as I said, your deploying will be done automatically. It will most commonly not use any shared storage. And if you are using some interpreted system, you will have to flush the caches every time you run deployments. If you don't run containers, if you run classical virtual machines, you will have a shared storage pool. It's just a service to use it as any other one. What you have to understand, and I'm going to sign this forever, this is some guy on Reddit who says, I swear to the big mainframe in the sky, whatever, I'll club the next developer who demands I set any file system 3 permissions to 777 so my code will work as intended. True story, last week, I have a client in panic who says, we have an old version of the website, it has the same metadata as our current website, and Google is flagging it full of viruses. And suddenly, our SEO ratings are dropping. What's going on? We are checking. Well, what goes on is the old website was developed by somebody who did exactly this. Everything was 777. It was hosted on a shared hosting. Some other site was penetrated. The guy who penetrated the other site just went around the server and placed malware on every single domain he could pick up. Yeah, the site is no longer in use, but it's still connected to your company. It still has your metadata. It still penalizes. Google is still penalizing your company because your web server is serving malware. Big deal. Second thing, when going to production, you're going to hear a lot about security context and mandatory access control. Security context and mandatory access control for web developers come to two things. There is a read-only context and a read-write context. Your PHP files are not able to have a read-write context. So either it's a PHP code, HTML code, whatever, or is a file you can read write. All you have to do as a developer in a well-organized DevOps methodology is tell somebody, this folder is where I write, this is where my code is. End of story. Somebody else will do it, but you will have to talk to people and tell them this. That's the whole point. The other thing you have to understand is performance. I had people tell me, look, it works a little bit slow on my laptop. Whenever you push that guys to the server, it's going to work just fine. Yeah, it is. It is if you're going to be the only user on the web server. Your pool of servers is 10, 20 times, let's say 100 times more powerful than your laptop. Maybe you have a crappy laptop. Your server in a pool is going to have 10,000 or 10,000 or 100,000 more visitors than your laptop, which has one user. So don't go thinking that you will have a better hardware than you have on your desktop. If your desktop is slow, you have a problem. That's the very important thing. The second most important thing is your memory will be limited per process, per action, per API requests. It doesn't have to be limited for every request. We can talk and you can get a lot more memory for some backend jobs which take it, but we will not as a default give you a gigabyte of RAM for every single request that exists, because then we would have a dead server. Key value storages are also going to change. You need to learn to use them. They're a good tool. Most people these days use Redis. I heard people recommend other solutions. There are cases when they're good, but this is a good default, a safe choice. It can be highly available. It can be deployed, either shared or on every instance. But basically, if you come and say, look, I want a dedicated Redis on every machine because it lowers latency and brings more scale, it does. But it also kills that single responsibility principle, and it also makes your caching impossible to invalidate. If every application server has its own version of key value storage and has its own version of cache, you can, and those servers go up and down all the time, then there is no way you can do cache invalidation. And cache invalidation can be crucial to a lot of projects. Also, I heard people who tell me, look, can we use it as a persistent storage? No. There are, I know one successful implementation where somebody practically implemented the entire transaction mechanism in memory, in its code, to use Redis as a persistent storage, but that's a very much of an edge case. Don't count on it. I know people who started to use it, and it's a very bad idea. Queues, there are lots of them. They're easy to design. They're highly available by design. All you have to know is that they exist. Why is this important? Because 10 years ago, 15 years ago, people have been using databases as queues. It still works. It's still a good solution, but you need to know that this stuff exists. Why? Because it does a lot of things automatically, like it's asynchronous, it has a mechanism for retrying, it will solve you a lot of headaches. So the moment you want them, the moment you want to develop something that looks like a queue, consider using a dedicated software for it. Full-text searches are also a big problem. I know a lot of people who ended up trying to do searches in the database. Hey, can I select something from where this like percentage, text percentage? Okay, this takes 10 minutes in the production database per one query. If you run 100 of these, well, we can go home. You know, we can close the website. Learn to use either Elasticsearch or Sphinx. They can be easily deployed, they can be easily used in a highly available fashion, and they will provide you with a very good tool not to bug the database with the stuff you don't need. All you have to, as I said, this is a very important tool to use. When it comes to document storage, I generally recommend people to switch to MongoDB. Why? Well, it's first thing you have to understand. NoSQLs are not SQLs. They are not relational databases. They're not a good place to store relational data. They call them database, document storage, they call them object storage. They're good for storing a single object. I want to store it, I want to retrieve it. Works fine. They are getting to be ACID compliant, they're transactional. but they are not good if you want to run queries which do something like a join in a relational database, because they're simply slow. Why do I have this slide twice? Okay, so that's the whole point. And also, using MongoDB or any other storage system which does document storage is an important thing to consider is read preference. These systems will allow you to read from not from the same node which you are writing to. When you connect to it, the system, every driver, every implementation I've seen is able to connect to the entire cluster. It's able to read the data from the cluster even if you don't give it data from all the nodes. It will automatically read and write from a single point. If you need to write a query which will take a long time, you need to learn how to send those queries to something which isn't the primary node. This is crucial for any performance if you want to run long-lasting queries on object storages, especially on MongoDB, because in most cases, when I see object storage implemented, it's usually MongoDB. What you guys need to know about, what about relational databases? The relational databases are the ideal place for storing data which is by its definition relational. It usually has asynchronous replication, and which will usually offer you a way to have more than one system. This is both a highly available mechanism, and it's also a mechanism for for sending queries to somewhere where you can run them with non-critical data. What you need to learn, first and foremost, if you use a relational database and if you're going to use it to store data, there is a ton of books on how to store data in relational databases. The theory has been around since the 70s. I have cases where I'm talking to people and they tell me, well, I have designed this database and there is a table for a product, and my table for a product contains the ISBN for books, shoe size, dress size, color, yada, yada, yada. And then we're spending 15 hours explaining to this guy, well, you know, there's something called entity attribute value model where you can store this in multiple tables and you can do it much faster, you will get good queries, you will get good performance, it scales well, and then you end up with a guy who says, yeah, but I'm modeling my data based on my ORM, and my ORM cannot load data from these joins. Well, that's boo-hoo, but you guys really need to model data based on what's been for, I don't know, 40 years, the theory how to model data. Look it up. It's most people who are designing databases these days probably don't even remember to tell you every single normal form, I don't know, by heart how it sounds in a relational form, but will design you a database which more or less confines with this to experience. It's a very important thing to learn. Also, don't overdo it. Most developers tend to use in-application logic because it scales better, and it does. But there are cases when it's a wrong approach. We'll get to that, because not everything scales well. What also you need to do, you need to start talking to your DBAs. There needs to be somebody who's taking an occasional look to the database. It needs to have some kind of indexes. There are many solutions, and the time is limited, so I'm just going to give you some ideas. If your database queries are slow, you can have an index which covers the entire query, and this gives you the opportunity to run the entire query from an index without touching the database. This is a huge asset. On the other hand, if you have too many queries, you have to understand that all those queries, all those indices need to be updated every time the data is changed, which is pulling you in another direction. So that you can have too little of them, you can have too many of them. The important thing is also to understand that without a covering index, there is no database engine that I have heard, and I don't think it's possible, which will not read your entire row from the table in a row-based database. So what does that mean? That means that you're going to read a lot of data from the disk. That means a lot of I/O. What you need to understand is that most relational databases, at least now Postgre from version 10 and also MySQL from way back, offer asynchronous replication and offer you the ability to have different indexes on the master and on the slaves. So maybe some of those could be distributed. Next thing you have to understand, this is not a development system. There will be privilege separation in the database. This is what I usually do as a very liked system for giving grants on an application. So no application is going to have outer table, drop table, all those things. Why? Well, first of all, you're not going to run outer table from your code because unlike, and this is stuff I'm talking about with developers all the time. You know, I get a millennial who's telling me, yeah, that works fine on my machine. Well, of course it works fine on your machine. You have 50 rows in a database. I have 50 billion. You know, it's going to take 4 hours and you're going to kill our website if you run it like that. And also, there are some other concerns when it comes to database privileges. Do you everybody know XKCD? Yeah, so this is one of my favorites. There is always a good thing to run defense in depth. There is no reason why any application, okay, there are reasons, but those are edge cases, why an application should be able to drop rows, outer tables, and do stuff like that. It's a big deal, you know. When it comes to asynchronous replication, I try to mention it, but you have to understand some things. Asynchronous replication is a very good mechanism which will give you a very recent copy of the data. Why is it important? Because a lot of queries don't need to be hit right away. And you should have a mechanism in your application to ask a slave for data. You have to understand, we can do it automatically, but it's never going to work well. I've seen implementations where we can route every query which starts with select to the slave and which starts with something else to the master. And then you tell me, I write a multi-statement. Or you tell me, hey, I want select last insert ID. Well, yeah, that's not going to be the same on the slave. So you will have to have in-app logic. Also, relational databases do not store objects. And running ORMs on a relational database usually mean that you are going to have huge performance penalties. Everybody knows this meme. This used to be trending a couple of months ago. ORMs are rapid prototyping tools. 2 more slides. Running it. You don't want them. These numbers are just from studies found on small databases. You can get 10 times faster results, 100 times faster results. So work with people who you work with. The biggest change that's going to change when you switch to a production environment is that you are going to have a team working with you. You need to start working with your team. The other changes you have to remember is 1, try to keep your stack as small as possible. This is not a trick. I've told you about 20 components, but I've seen people who use ZeroMQ, Amazon SQS, and RabbitMQ on the same application. For crying out loud, pick one. Use the right one, so don't store objects in a relational database, don't store relations in a, don't use multiple tools for the same jobs, and always be aware that your application will have millions of users. If you have a small website, which is easily cached, you would not be there. You would be still running that WordPress, cached, that's it. So you are deploying your applications for production. That means you will be running it for millions of users. Thanks.